This is the first part on divisibility. So we first define what divisibility is. So for those of you who already know about it, then it will just serve as a review. If you have a and b to be integers, such that your a here is not equal to 0, then we say that a divides b. It's written as such. If there exists an integer c such that you can express b as a times c. So here you have c to be your integer. Sometimes instead of simply the variable c, you make use of k sub 1 or k para mas madaling matandaan that it's actually an integer there. So there are other ways of saying a divides b. The other forms of saying a divides b. A divides b. B, okay, ito siya. B is a multiple of A or B. A is a factor of B. That's correct. What are the examples of divisibility? So we can have the following. You have 3 divides 6, since you can actually rewrite 6 to be equal to 2 times 3, where your 2 here is an element of your integer. So similarly, you have 6 divides 24. Why? Because you can rewrite 24 to be equal to 4 times 6. It's a factor of 4 and 6. So 4 times 6, where 4 is an element of z. And down the line, you also can say 8 divides 0, because 0 is equal to 0 times 8. And we know that 0 is definitely an integer. Similarly, you can have the following. Okay, so I guess you are familiar with divisibility. Note that you have any integer n except 0 has just a finite number of divisors. That is, if a divides n, where a and n are positive integers, then you would have n equals a times k for some integer k. Another thing is that if you have k is a positive integer, then when you have n equals a times k, then that should be equal to the value which is greater than or equal to a. Why? Because you have a factor k there, and remember that it's always an integer. So it's either, if it's 1, then it will be equal, otherwise it will be greater than or equal to the value a because of this factor k. You have any non-zero integer, n can have at most twice times n divisors. Okay, so what does it mean? Every integer must have at least 2 divisors, namely 1 and the number itself. So if it's a prime number, then you only have 1 and the number itself. 0 is divisible by any number except itself. You are familiar with this? 0 cannot be divided by 0, or 0 is never a divisor of, because it will become undefined. And we have, it's possible, if it is possible to divide a number m, then it is equally possible to divide its negative. So you can divide it by a negative number. If it's possible to divide 2 numbers, m and n, individually, then it is also possible to divide their sum. So what is the transitive property of divisibility? You have, for transitive, you have a and b and c be integers. Then, if a divides b and b divides c, then what happens? A also divides c. So how are we going to prove that? You recall the definition first. If a and b are integers with a not equal to 0, then a divides c, b written as such. If there exists an integer c such that b is equal to ac. So you make use of the definition to prove the following lemma. So let's start. Suppose this is given that a divides b and b divides c. Then again, by definition, there exist integers m and n such that your b can be expressed as m times a, where m is your integer there, and c can be expressed as n times b. So that c now, the c can be rewritten as, we have your b is ma. We have ma, or n times ma. You will have n times m. You can group together because these are integers, so by associativity, you have c is equal to nma. But what is nm? We know that n and m are supposed to be integers. So when you have a product of two integers, it is also an integer. So nm is also an element of z, so that a divides c. We have proven that the lemma is actually true. So we say an integer n is a linear combination of a and b if we have the following. N equals ax plus by. So you say linear combination, you can actually rewrite it in such a manner. N equals, you have a factor x, integers x, and then integer y. Example, 7 is a linear combination of 3 and 2. Since you can rewrite this as 7 equals 2, this is supposed to be your value here, and then your value 3 there. So 2 times 2, 1 times 3. So clear yung transitive property at saka yung linear combination. Is that okay? Yung first lemma? Hello?
Yes, ma'am.
Okay.
Yes, ma'am.
Very good. Let's go to the next one. The linear combination lemma. The linear combination lemma says that if you have a, b, and c to be integers, and if c divides a and c divides b, then the linear combination of this one, xa plus yb, for any positive integer xy, c divides the linear combination xa plus yb. And how do we prove that? Again, c divides a and given. No? So suppose c divides a and c divides b. We make use again of the definition. Then there exist integers m and n such that we'll have a is expressed as m times c, and this time b is expressed as n times c. So where m and n are supposed to be your integers. If you assume that x and y are arbitrary integers, then you will have xa. Remember, kailangan natin to. Dito tayo dapat, no? So xa plus yb equals x times, our a is mc, so m times c. And our b is n times c, so you have n times c. Therefore, again, you can combine this time. You have your c here, you can take out your c and come up with xm. And then from here, pwede tanggalin dito yung c again. I guess you are familiar with that one. Let's see, pen. Associativity and commutativity is a property of integers, di ba? So, pwede yan siya ma-rewrite. Bale, ito siya, pwede ma-rewrite as, pen? Ito, ma-rewrite ito as x can have x, m. Tapos, mag-group yan together. C plus, you can have yn. Associativity by associativity. Tapos, common yung factor na c. So, pwede na yun siya. C times xm plus yn. So, those are properties of integers. Associativity and commutativity, and it's also this has a property which is distributivity. So, ito yan. Now, since xm plus yn, we know, again, the sum of integers belong to the set of integers. Then this one, c, xm plus yn, can be replaced as simply one integer. So that you have C divides XA plus YB as desired. Okay? Klaro siya ang linear combination na lemma? So meaning to say, if an integer divides two other integers, then it divides any linear combination of these two integers. What are the properties of divisibility? This property we have, if a number n is divisible by m, then it is also divisible by the factors of n. The second property, if a number n is divisible by both p and q, where p and q are co-prime numbers, then n is also divisible by the product. Remember, and there are your natural numbers. If a number n is a factor of two numbers, s and t, then it is also a factor of the sum. Therefore, when n is a number n, is a factor of another number n, then it's also a factor of another multiple. Anti-symmetric property of divisibility. If you have a and b be non-zero positive integers, if a divides b and b divides a, then a is equal to b. If you take a look, it says anti-symmetric. Sanay kasi tayo sa symmetric property. Diba? So the anti-symmetric says that if a divides b and b divides a, then a equals b. So, for the proof, by definition again, so dapat at this point, mamaster nyo na yung definition ng divisibility. So, suppose a divides b. Anong ibig sabihin ng a divides b? Then, there exists an integer m such that your b is equal to m times a. And b divides a means there exists an integer n such that this a here can be expressed as n times b. Sometimes, instead of itong n and m, sometimes, mas madali gamitin yung k sub 1 na integer. Ito, usually ginagamit yan. K sub 1 para malaman na, tapos para hindi makalito. Kasi minsan nakakalito pag pare-para silang letters na ganyan. Tapos K1, K2. Sometimes this one is better, a better notation. That is, when you have a divides b, there exist integers k sub 1 and k sub 2 such that you can express b is equal to, you have, instead of m, so you have a times k sub 1, and you have there a equals, okay. You have press this as your n, so that will be your k sub 2 times we have your b. Okay? Pero, yun natin yan. Pahin ko na lang muna. Palalo kayo malito sa notations. So, take a look at that. Notice that both m and n are positive since both a and b are. And then, we have next. That is, a is equal to n times b, and n equal to n times ma. So you replace this time your b to be your ma, and your, again, by associativity, and associate n and m, come up that one, then you have this one. But n, m, this one, are supposed to be integers. So the result is another integer there. So meaning to say, n, m equals 1. It cannot be other integer because it's a equals a. So that means to say itong nm na to is equal to 1. So in particular, at this point, n equals 1. And you come up that with a equals b. And that is what we are supposed to prove. Multiplicative property of divisibility. If you have a, b, and c are integers, if A is not equal to 0 and A divides B, then AC divides BC. Ano yan? A divides B, then AC divides BC. Anong nangyari? Meron lang inintroduce na quantity which is C. Here. Diba? So how are you going to do this? Similarly, you come up with the position which is A divides B. You would like to have this. AC divides BC. Anong dapat natin i-introduce? If A divides B, then you have this. B equals a quantity n times A, where n is supposed to be your integer. No? Yeah, that one. Kailangan natin ng AC divides BC. So, if you have BC, that becomes NC. Saan yung NC natin? NCA. Ang BC kasi, ang B kasi kay NA. Diba? NA ito. Dapat yan. So, dapat dito, before you come up with an NA, kasi yan, your BC is actually NA times your C. But then, because of associativity, hindi pa muna associativity, commutativity, you can actually rewrite this as, pwede rin associativity mauna, and then associate this, AC, and then you can commute. That is AC times, commute equivalent, times n. So, pareho lang, no? Come up with that. So, those are the properties, mga basic properties para makuha niyo. So, because of that, AC and nakuha niyo na yan. AC divides BC. Okay. Since C is not equal to 0, it follows that AC is not equal to 0, so that AC and BC as needed. This one actually is a lemma. Its proof needs the principle of mathematical induction. So, let's see. So, use the mathematical induction. Mathematical induction, which was discussed in a previous video clip. So, we start with the following. Since A divides B, then this implies that A divides B for K equals 1. Okay. So, this is trivial. Kasi pag mathematical induction, di ba, we start with when K is equal to 1. So, this is trivial. A divides B. The case for K equals 1 is trivial. You have to verify for initial values. That's the first step. Verify for N, this time K. K man yun. So, N equals 1. So, kasi yan, no? N yan. So, for N equal to 1, then you will have A divides B. So, okay siya. Next thing to do is, you consider that A to the K divides B to the K. Meaning to say, you assume that it is true for N equals K. So what are we going to show? We need to show that this one, we need to show that it should also follow that A to the K plus 1 divides B to the K plus 1. Yun yung next na dapat na ma-prove natin, no? Na ma-show. You have to show, you need to show at this point, you need to show that A to the K plus 1 divides B to the K plus 1. For this assumption, that is assumption that A sub to the k divides B to the k, then we have the following. That is, B to the k is equal to M to the, that is A to the k for some integer M by definition. And because of this, if we try to rewrite this as, if we try to multiply both sides by B, multiply, di ba, anong klaseng property yung ipag i-multiply natin ang dalawang equal values with the same value, tapos equal pa rin siya. Anong tawag na property yon? Can you remember? Multiplication property of equality. Di ba? You can do that. So, bale, from here, ang gagawin is, wait, you multiply the same value. You have B to the k times B is equal to M A to the k times B. Yan ang ginawa. So, that's why B to the k times B, or pwede naman siyang may interchange because of your commutative property. That's your B to the k times B is actually your B to the k. Ang understood na exponent niya is 1. Diba? So, B to the k plus 1 na yan siya. Ito. Then, itong sa kabila, M A to the k times B is the same as, again, pwede nandito ang B sa front. B to times M A to the k. Because of the commutative property of your integers. So from there, you can rewrite this as Bm. We can, by associative property, ito, itong Bm, may associate, you can write as Bm times A to the k. Again, this one, M prime A M, because your B here is a quantity wherein A divides B, diba? So, you can rewrite as such, M prime AM, where your M prime is another integer, but then M prime AM, the entire thing is an integer M. So, you have A, K, raised to the K plus 1. So that, kasi itong A dito, may A to the 1 yan. So, you have A to the K plus 1. Where M prime and M are integers. We come up with this by the principle of mathematical induction, because you have shown that A to the K plus 1, whenever A to the K divides B to the K, you had shown that A to the K plus 1 divides B to the K plus 1, then by the principle of mathematical induction, you now conclude that it is actually true. So every non-empty set of positive integer contains a smallest member, meaning well-ordered principle. So we are going to make use of that for your division algorithm. What is your division algorithm? The division algorithm theorem says that if you have A and B are non-zero positive integers, then there are unique positive integers Q and R, such that your A can be expressed as BQ plus R, where R is the remainder, which is greater than or equal to 0. So your remainder can be equal to 0, but it should be less than the quantity P. Remember, we are talking about integers, positive integers, Q and R. So A can be expressed as BQ plus R, where R is between 0 and P. How do we come up with the proof? How do we prove that this theorem is true? So we should show that that quantity actually exists. So prove existence. So you consider a natural number b greater than 0. And you have S be the set of multiples of b that are greater than a. Namely, you have your S is equal to all the quantities will be a set containing bi, where I is an element of your natural number and bi is greater than a. So what do we have here? You have this S is supposed to be non-empty because a times b is greater than a. So because of the well-ordering principle or axiom, that S must contain at least an element, say, yung maliit na element, bk. B times k, and k should not be equal to 0, wherein k is equal to q plus quantity 1. Your bq is less than or equal to a, and since bk is the least multiple of b greater than a, then what do we have? You have a natural number r, which is a equal to bq plus r, where your remainder is less than or equal. Actually, so if we assume that r is greater than or equal to b, then there exists a natural number m greater than or equal to 0 such that your b plus m is equal to r. Let us see. Okay, tuloy-tuloy ko na lang ito. How about uniqueness? If suppose your A is expressed as BQ1 plus R1 and BQ2 plus R2, where R1 is between 0 and B and R2 is between 0 and B. We are to show that these one are the same. So suppose your Q1 and Q2 are equal. Then, wala nang problema. Mean to say the remainder is also equal. Now, what happens if Q1 is less than Q2? Then you can express again your Q2 as, kasi mas malaki yung Q2. So Q2 equals Q1 plus N. Okay, for some natural number N greater than 0. Pero ano ibig sabihin yan? Ang R1 ninyo is A minus BQ1. Ito, A, di ba R1? A minus BQ1, pailipat doon, equals BQ2, kasi ang A ninyo is BQ2 plus R2. So, A is replaced by BQ2 plus R2 minus itong BQ1, which is equal to Bn, B times N, plus R sub 2. But that is supposed to be greater than or equal to Bn, B times N, greater than or equal to B, which is contradictory to what we had assumed that R1 is, diba? R1 here is less than B. So Q1 cannot happen. Q1 less than Q2 cannot happen. So therefore, your Q1 equals Q2 as desired. This theorem, the division algorithm theorem, is best studied making use of an example. So you have an integer A, which is of the form BQ plus R. There exist integers PQ are such that A equals BQ plus R. So, ang ibig sabihin lang ng division algorithm is that kung meron kayong integer, ma-express siya as a product of two quantities as long as this integer is greater than this quantity. So, BQ plus R. Division algorithm, in certain sense, measures all divisibility of B using your remainder R. Ito, tingnan natin, making use of your division algorithm. You have to show that 3 divides this one. What is divisibility again? You say A divides B. So 3 divides ito, mean to say there is an integer, natural number integer, such that this one, A divides B, B is actually equal to a quantity times a factor between that quantity and the value that it divides. So, what do we need? We need to show that a squared plus 2, itong a squared plus 2, is of the form 3 times k for some k. Ito dapat mapakita siya na it's a factor kasi 3 divides this one. So, it should be a factor 3 of 3. So, there is a factor 3 and we have an integer k for any natural number a. So, by division algorithm, a has exactly one of the forms. Either 3k siya, ibig sabihin ng 3k, exactly divisible by 3. 3k plus 1, okay, you have a remainder 1, or 3k plus 2, you have a remainder 2, not divisible. If a is equal to 3k plus 1, for some k, then what will happen? You have, replace natin ng a by 3k plus 1. So 3k plus 1 times yung a squared is replaced by 3k plus 1 squared plus 2. And then you operate 3 times 3k plus 1. Ito, mamultiply itong 3k plus 1 squared. What do we have? That becomes 3 squared, 3. Ito, what do we have here? Plus 2, marirewrite nyo as this. Kayo na lang mag-ano nito ha. Mag-solve yan kasi algebra yan. Which shows that we have a factor 3 there. So this factor 3, hindi maklaro. This one, this factor 3 shows that, kasi originally this is your a squared plus 2, shows that 3 divides a times a squared plus 2. If on the other hand, a is equal to 3k plus 2, kunyari ito, for some k, then again you replace that your a by 3k plus 2, then you have a squared by 3k plus 2, and you come up again with this quantity. Again, 3 divides a squared plus 2. But if it is of the form 3k, notice that your a here is replaced by 3k, and your a squared is replaced by 3k, so it becomes 9k squared and plus 2. So again, meron tayong factor na 3. Therefore, in all possible cases, 3 divides a squared plus 2 for any positive natural number. Klaro siya ang proof? Hello? Are you still with me?
Yes, ma'am.
Oh, sige. Oo, sige. So, okay lang, ha? Naintindihan
Yes,
ka yung number 3.
Mama-upload lang tong file.
I'm going to upload this one later. Okay?
Okay.
Sige. Prove that for each natural number n, 7 to the n minus 2 to the n is divisible by 5. So, if we need this to be divisible by 5, then it should be a factor of 5. Diba? Now, 7 to the n minus 2 to the n is by mathematical induction, for the first value, we can replace n. When n is equal to 1, you have 7 to the 1 minus 2 to the 1 will give you 7 minus 2, which is 5. When n is equal to 2, what will you have? 7 squared will have, when n equal to 2. When n equals 2, you will have 7 squared minus 2. Oops. Minus 2. Ano yan? Sorry. 7 squared minus 2 squared. You will have 49 minus 4. So that should give you
45.
45. Visible pa rin. Pag hindi pa kayo kontento, i-try. N equals 3. You will have 7 cubed minus 2 cubed. So that should be a value which is also divisible by 5. Now, so what do we do next? We assume that 7 to the k minus 2 to the k is divisible by 5. K element of P. Ang ibig sabihin yan, we assume that 7 to the k minus 2 to the k is divisible by 5. We need to show that 7 to the k plus 1 minus 2 to the k plus 1 is also divisible. Yung magsunod yung ballpen. Divisible by 5. So, let us take a look on 7 to the k plus 1 minus 2 to the k plus 1. 7 to the k plus 1 minus 2 to the k plus 1 is the same as, diba, 7 times 7 to the k minus 2 times 2 to the k. And 7 times 7 to the k, and if you have this, you can, anong ginawa dito? Nag-add tayo ng, you have 7 times 7 to the k, which is this, minus 7 times 2k plus 7 times 2 to the k. So, nag-add kayo and nag-subtract. Anong property ang ginamit natin? Gamit tayo ng, may dito? Add tayo ng 0. 0, adding 0 to any quantity, because 0 is an additive identity, diba? When you add 0 to any number, then you do not actually change. Alam niyo yung ginagawa natin, yung mathematical manipulation. Try to make use of, we manipulate this quantity by adding and subtracting the same value. So you add minus 7/2 to the k, and you add plus 7/2 to the k, which is actually your 0. So when you do that, then you group together this one, these two. So when you group that together, you come out with 7 times 7 to the k minus 2 to the k. You factor out 7, plus this time you factor out 2 to the k. So this one, 2 to the k, and you're left with 7 minus 2. But remember that we already assumed that 7 to the k minus 2 to the k is divisible by 5. So 7 to the k minus 2 to the k, this is divisible by 5, okay? And 7 minus 2 is 5. But what is 7 minus 2? Which is 5. Again, divisible by 5 yan. So if you have a value divisible by 5 plus a value divisible by 5, then you have actually a linear combination which is divisible by 5. Therefore, this quantity, 7 to the k plus 1 minus 2 to the k plus 1, is also divisible by 5. Hence, by the principle of mathematical induction, by mathematical induction, you have 7 to the n minus 2 to the n is also divisible by 5. Okay? Kung hindi nyo pa master yung PMI, you have to master it, ha? Next, let's take a look. These are your exercises. It's already 6. So the first set of exercises show that the sum of two even or two odd integers is even. Also show that the sum of an odd and even is odd. Let me see. Asa na yung papagawa? You can just do this as exercises. Let me see. Ano ba ang papagawa ko sa inyo? Ito. So your activity 3, this will be your activity 3. Diba? Activity 1 was to watch the video clip. Activity 2 was to solve the quantities doon sa inyong PMI. And then, activity 3 is to do exercises B. So, activity 3, submit solutions to exercise B. So these are the, and take a look at these books. Atong si Carmichael, it's online. So you have numbers. And you can also take a look at this. The other references are my lecture notes, the old lecture notes that I have. And also by Lars Ake and Doug. Sometimes I make use of other texts, ibang books yung ginagamit ko. So as I give you the lecture notes, I also give the other resources. I think we'll end with that one.